Alright, so this is my final project for 116A. I call it the Robot Builder and Renderer. So with this project, I wanted to expand upon the skeleton builder that I created for Project 3. The first topic that I'm going to cover here is adding support for rigid skin geometry. So with this, I would support loading and binding of meshes in the form of OBJ files to the joints of the skeleton that I created with the skeleton builder to create a skin over the skeleton so that when the joints rotate, the skin rotates with it. The second topic that I want to cover is ray tracing. So with this, I will render the character with smooth skin using the ray tracer that I developed for Project 2. Alright, so here we are in Visual Studio. I have the Open Frameworks viewing window open, and as you can see, I already have a basic scene set up with 3 point lights and a plane. So let's go ahead and start off by adding in a skeleton. I'm going to do a basic skeleton that consists of only 2 joints and a single bone, and I'm going to go ahead and map on a mesh to it. So the mesh is mapped only if you have the child joint selected. And I'm going to start off with this simple structure right here because I want to explain how shading and rendering works. So if I render this image and I have the smooth shading option disabled, I will go ahead and show you the result that I get. As you can see, this is not smoothly shaded at all. It seems as though the shading kind of jumps around a bit when you transition between the different surfaces. This is because I use the surface normals to calculate the shading as opposed to interpolated normals. So if I re-enable smooth shading, I'll actually use interpolated normals to calculate the shading with my Phong shading method, and you'll see a much smoother image. Alright, and as you can see right here, using the interpolated normals in my Phong shading method actually has a huge impact on how the shading looks, and you can see it's a lot smoother in terms of shading, and it transitions nicely as the light gets dimmer as you go away from it. So that's pretty nice. So let's get into building the skeleton now. Alright, so I'm starting off with an empty scene right now, so let's go ahead and actually drag and drop in a model. So doing this when we have no joints selected, you'll see that it goes ahead and renders the model right at the origin. This model right here is actually not able to be ray traced because I only ray trace the models that are attached to a joint. But that's okay because we're going to use this just as a reference in order to create the skeleton right now. So if I go ahead and hit the J key, I will add in some joints, and this is going to take kind of a bit, so I'm going to go ahead and skip around a little bit, and I'll meet back up with you guys in just a second. Alright, so here we are with the completed skeleton. I'm going to go ahead and remove my reference mesh, which I can do by pushing the D key, and we'll see the skeleton by itself. I'm going to actually go ahead and save this as well. If I hit S, I'll save it to a script file for later. And let's get into how it works with adding the different meshes onto the different pieces of it. So if I have a joint selected and I go ahead and drag and drop a mesh onto it, let's do the head first. You can see that it renders it actually displays the mesh right here at the center of the bone where it's connected to the child joint. So I'm going to do that for each one of these different joints right here. I'm going to go ahead and attach a mesh to them, and I'm going to actually speed up this process because it will take kind of a little bit of time. So I'll see you guys in just a second. Alright, so I finished mapping on the different mesh pieces to this skeleton. So as you can see right here, each of these different pieces are mapped perfectly at the center of the bones that they are aligned to. If I select a joint and I push up or down, I can change that actually. I will go ahead and move it up or down the bone, and this is helpful for when we want to arrange specifically how the models are in a relation, basically their position in relation to the bone. So let's go ahead and do that right here. So I'm going to show you guys now that it supports translation. As you can see, I can translate the different joints and the meshes will follow through with it. And they also support rotation. So if I rotate this in the z-axis, it rotates in the z-axis, rotate this in the x-axis, rotate, let's do this one in the y-axis. Boom, does that. So let's go ahead and arrange it how I want it for my final rendering. And let's go with that. So that's a pretty cool little pose right here. And then I'm going to go ahead and render this image. So this is going to actually take quite a while because it's going to have to go through and iterate through each of the triangles that compose this mesh. So I'll see you guys in about an hour. Alright, so I got the final rendering of the image done. So let's go ahead and take a look at what it looks like. And bam, that looks pretty good. It's shaded smoothly and everything. I'll probably need to translate some of these joints a little bit because you can see they're kind of overlapping right here and aren't exactly where I want them to be, but it's okay. So let's go ahead and do one last rendering actually. So okay, cool. So that's a cool another pose to do for it, and I'll go ahead and render this one out. All right, so this one finished rendering. Let's take a look at the final image. Oop, gotta select it first. And there we go, that's the final image. So that's been my project, guys. Thanks for watching.